All right, today we're going to dive into a really fascinating paradox at the heart of AI. How can a machine be smart enough to master something as complex as chess, but then totally fail at a task that seems so simple, like, say, baking a cake? Well, the answer lies in a whole new way of designing AI, and we're going to unpack that right now.
So let's really dig into this paradox for a second. On one hand, you have an AI that can beat a chess grandmaster, which is just an incredible feat of strategic thinking, right? But then on the other hand, you ask that same kind of intelligence to bake a cake, and you might just end up with a burned-down kitchen. So what gives?
And that is the core challenge. You see, moving an AI from the very predictable digital world of a chessboard to the messy, unpredictable physical world of a kitchen, that is a massive leap. So what is it that makes a long string of simple actions so incredibly difficult for a machine to get right?
Yeah, there's a name for these. They're called long horizon tasks. See, unlike a single, very calculated chess move, baking a cake has this long sequence of actions, and at every single step, something can go wrong. Just one tiny mistake, like grabbing the salt instead of the sugar, and the whole thing is completely ruined.
So, the way we used to do it, what's called a flat policy. It's kind of like trying to write an entire novel in one single sentence. It's too much to handle at once, and it breaks really easily. The big breakthrough is something called a hierarchical policy, which is much more like having a smart manager and a skilled worker. One does the planning, the other does the executing. And here's the basic idea behind it. In hierarchical learning, you've got this high-level manager that's thinking about the big picture goals, stuff like get the pot. And then you have a low-level worker policy that handles all the nitty-gritty details, the super precise motor controls you actually need to go and grab it.
And this really breaks down that flow. The manager is thinking slowly, strategically, figuring out the next major step. And in the meantime, the worker is acting fast, tactically, just to get that one job done. It's this division of labor that makes the whole system so much more efficient and, honestly, way more resilient.
Okay, so let's put ourselves in the driver's seat. Imagine you're the AI architect building one of these systems. You're going to be faced with three really critical decisions. And these choices, they really represent the core technical pathways you have to pick from.
So first up, how are they even going to talk to each other? Second, how are you going to train them so they actually work together as a team? And third, what's the timing going to be like? How often does the boss give out new orders? Let's walk through these choices, just like a real AI architect would.
So, decision number one, it's all about communication. The language, or what we call the goal representation, that the manager uses to give commands to the worker, well, it's absolutely critical for the whole system to work.
And you've got a few pathways to choose from here. You could use simple text commands, or maybe show it images of what you want done. You could even use something like GPS coordinates for navigation. The real trick is finding a language that's expressive enough to handle complex stuff, but also structured enough for the AI to actually learn from it.
Okay, let's check out that first pathway, just using plain old text. This is incredibly flexible, right? A simple command like pick up the metal scoop can guide a huge range of actions. That makes it a really powerful tool if you're building a general-purpose robot.
Or you could go down a totally different path, a visual one. Here, the manager literally shows the worker an image of what the goal looks like. This is fantastic for tasks where the final appearance is key, and it has this really cool advantage. It works even for objects the AI doesn't have a name for.
All right, your next big challenge is training. How do you make sure the manager and the worker are perfectly in sync? Because if you train them separately, you can get a real mismatch. The manager might start giving impossible commands, asking the worker to do something it just physically can't do, and then the whole system just grinds to a halt.
And last but not least, you have to decide on the timing. When should the manager give out a new order? You could wait until a goal is complete, but that's pretty risky because it's actually really hard to know when a task is truly done. The safer bet, and what most systems do today, is to just give a new order every few seconds. It keeps the AI from getting stuck in a fatal loop.
Okay, so that's the blueprint, the theory. But the big question is, does this whole hierarchy thing actually work in the real world? Let's take a look.
Oh yeah, it absolutely works. This is not just theory. These are actual commands from a real manager policy, guiding a robot to make trail mix. It's breaking down a pretty complex task into these simple, bite-sized steps.
And what's really cool about this is that the system can learn on the fly. If the robot is about to mess up, a human can just jump in and correct it with a simple command.
and the system learns from that feedback, so the manager actually gets better at guiding the worker. It's just like a great boss training a new employee. And listen, the performance boost we're talking about here, it's not some tiny incremental improvement. We are talking about a significant, measurable leap forward. Get this, the research actually shows that when an AI learns by watching humans, that's a process called imitation learning, these hierarchical systems outperform the old flat policies by 34%. That is a huge improvement in the AI's ability to actually get the job done.
And check this out, this is a perfect example of that other pathway we talked about. Instead of text commands, this robot's manager is sending it a series of goal images. It's almost like it's watching a little flipbook of the future it needs to create, guiding it step by step to successfully open that drawer. So everything we've looked at so far, it involves us, humans, as the architects. But what happens if we kind of step back? What if we let the AI start designing its own approach? Well, that's the next frontier. This brings us to this cutting-edge area of research called skill discovery. And the ultimate goal here is to create an AI that doesn't just follow our pre-made plans, but one that actually learns to break down problems on its own, discovering the building blocks of a solution all by itself. And that really leaves us with the ultimate question, doesn't it? What happens when the AI stops just following the recipe and starts writing its own? That is the leap from just simple execution to true, genuine, creative problem solving. It's a future that's both incredibly exciting and, yeah, maybe a little bit unnerving. And it's happening right now.